Assalamualaikum warahmatullahi wabarakatuh. I am Hendy Irawan. Welcome to Introduction to Artificial Intelligence. And today we will discuss one of the simple but also popular algorithm that is called decision tree. Before we implement the decision tree, first we have to know the relationship between attributes. We will use this example of a dataset, employee recruitment data. So we have 12 applicants, 12 records, and there are three of attributes or three input attributes: GPA, psychology, and interview. For GPA attribute, we have three possible options: good, average, and poor. For psychology input attribute, we also have three possible options: strong, moderate, and weak. And for interview input attributes, we have two possible values: proper and unsuitable. So the goal of this learning is that based on the input attributes of the applicants, we want to decide whether this will be the output attribute, whether the applicant will be accepted or not. Okay. So let's move on. Okay. So we want to know how to determine if the applicant should be accepted based on the attributes of the input attributes of the applicant. Okay, so first, the one thing that we can do is that we can determine based on a specific input attribute. For example, in this case, if we have this dataset, then all of the applicants that have a proper interview will be accepted. Okay, so if this is the dataset, then it will be simple. So you can say accepted is equal to interview. Okay. So in that case, the decision tree will be just as simple as this one. So based on the interview, if the interview is proper, then accepted is yes. If the interview is unsuitable, then accepted will be no. And we can do this in a programming language like this. But what happens if the data is like this? As you can see, even if these applicants have a proper interview, they are yes, but there are also other applicants that does not have a proper interview and it's still accepted. Okay, so what will be the decision tree for this one? Okay, maybe it's because the psychology is moderate. But the problem is, even if the psychology is moderate on this one, but in this case, it has a moderate psychology, but this one is not accepted. So the different attributes may affect the output or the label in different ways. So in this case, maybe we can have a decision tree like this. If the interview is proper, then the applicant will be accepted. But if the interview is unsuitable, then we decide based on psychology. If the psychology is weak, then the applicant will be rejected. And if the psychology is moderate, then we decide based on GPA, and if the GPA is good, then the applicant will be accepted. But if the GPA is average, it can be accepted as well. But if the GPA is poor, then the applicant will be rejected. And if the psychology is strong, then what happens? We don't know. Why? Because there is no data in there. Okay. And if we turn that decision tree to programming language, then we can write it down like this. As you can see, it can get complex, but it can also be flexible. But the problem with this is that we have incomplete data. Sometimes there are missing values, and then sometimes we have duplicate values. So how to define a rule, and then we are using that rules, we are able to generalize the unseen data points. For example, even if the interview unsuitable and psychology is strong, then the algorithm should be able to decide the applicant goes to accepted or rejected. So these are the goals that need to be fulfilled by the learning algorithm for decision tree. So we have, if we have a lot of data, and if we have incomplete or missing data, and we want to find the rules that fit the data, or we want to find the general rule to fit data that are unseen, or that we want to find the difference between two similar things, or we want to find the similarities of two different things. So, what is the decision tree learning algorithm? Decision trees themselves is a set of rules for classifying data using attributes. And the tree will consist of decision nodes and leaf nodes. And then a decision node has two or more branches, and each of them will represent the values for the attribute that is being tested. And then after each branch, they will go down and down until it reaches a leaf node. Then there will be a homogeneous result. And then after that, there will be no more testing or of classification. Okay, so it's similar to what we have discussed and shown before. And one algorithm to learn a decision tree is called iterative dichotomizer tree or ID tree. And this algorithm is based on mathematical formula. It is invented by Jaros Quinlan, and it uses information theory invented by Shannon. So we will learn, we'll have to learn more about the formulas of the information theory that we will also discuss in this course before running the algorithm itself. Okay, so what is this information theory? It is a study of quantification, storage, and communication of information. And the two concepts that we will use in ID tree algorithm are Shannon entropy and then information gain. So first, the Shannon entropy is a formula to calculate the homogeneity of a sample, whether a sample is all the same or all very equally distributed, or the sample is chaotic or random. And then the information gain is a formula that we will use to select the most useful or important attribute during classification or during learning. Okay. So we will start about entropy. This goes back to the entropy of thermodynamics. It is how it is ordered or disordered. And then how about Shannon entropy? So in this case, applied to information theory, the Shannon entropy calculates the homogeneity of a sample. If a sample is completely homogeneous, it will have an entropy of 0, and if it's equally divided, the entropy will be 1. We will see later. And the formula is actually quite simple. So we sum of for all of the possible values in that attribute, we sum using pi, and pi here is the probability of that state or value in that attribute. And let's take a look at this example. Now, what do you think the entropy of this attribute will be? Okay, based on the previous description, if all attributes are the same, it will be homogeneous. If all of the rows, in this attribute having the exact same value, then it will be completely homogeneous. So because all of this is yes, the possible values are yes and no, right? So the entropy should be 0. So we can prove it. What is Py? Py is the probability of yes here. Py will be 4 divided by 4 because we have 4 yeses and then divided by the count of data, which is 4. So this is 1. And 1 log 1 minus 1 log 1 and then minus 0 log base 2 of 0 because there is no, we have nothing that has no here, so this is 0. So the entropy is 0. Okay, so we can prove it. So what if the data is like this? We have yes and no and then yes and no. Based on the description, we can see that the definition is exactly equally divided. Yeah. So we have exactly 2 yeses and then 2 no. So which means the entropy should be 1. And we prove it, yes. So that means the probability of yes here is 2 divided by 4, and then here is also 2 divided by 4. So the entropy is 1. Okay, so this is completely equally divided. Yeah, all of the possible values are equally divided. And then between 0 and 1 will be how chaotic, that means the entropy is more or less random. Yeah. Okay. Next concept is information gain. So information gain is a formula to measure the effect of contribution of an attribute to the output label. So we will see later what the effect or contribution or effectiveness means. But in calculating it, first we need to calculate the entropy of the attribute itself, and then we need to calculate the entropy of each of the values of the attribute. Okay, and again, the information gain is based on the output label. Yeah, so we need to know the attribute itself, and then we also need to then know that that is relative to the output label. Okay, we will follow up with that in the example. And then this is the ID3 pseudocode algorithm. So what it means is we have six steps, but steps 2 to 5 will be repeated. First, we need to know what is the attribute that will be classified, what is the output attribute or label in a table called R. And we will have multiple tables after this. And then we need to compute the classification entropy. So this is the entropy for the label or the output. And then for each of the attributes, the input attributes in R, we need to calculate the information gain. Again, this is relative of the output or classification attribute. Select the attribute with the highest gain to be the next node in the tree. So the information gain is used to calculate or select the most important attribute next. We'll see later, yeah. And then we will remove the node attribute, and then we will create another table. So this is a reduced table that we will call RS. So we will see what I mean by multiple tables, yeah. And then we will repeat back to step 2 to 5, 2 to 5 again until all of the attributes have been used, or that the rest of the rows have the same classification value or the same label or same output. All right. So what is the example? We will use this employee recruitment data. As you can see, it's not so simple. The relationship between the input attributes and then the classification attribute or the label or the output. Now first we have an iteration because the algorithm is called ID3, iterative, right? So the first one, we will need to calculate the entropy. Okay, we will need to calculate the entropy of A. Here means accepted attribute, yeah. We call this the classification attribute or the label or the output. And how many possible values? We have two possible values, yes and no. So that's why the formula becomes we have a P of Y, probability of yes, and then the probability of no here. So how to calculate probability? We need to calculate how many data are there. We have 11. And then we have 8 of yes, and then we have 3 of no. Okay, and then we put it here, and then now we have the entropy of the accepted, okay, attribute. Next one is that we want to know the information gain of the GPA attribute. So if you recall, we have 3 attributes. So we will start with GPA first. Now, if we want to calculate the gain of GPA, okay, we want to calculate the gain of the GPA using the accepted one. So what this means is that we want to know how effective is GPA attribute in predicting the result of accepted. Okay, so this is how important is GPA for being accepted. Okay, now mathematically we calculate this by calculating the entropy of accepted itself, which we have already done in the previous step. And then we will also have a sum. This is a sum of minuses. Yeah? We have a sum of each of the possible values of GPA of this input attribute. Yeah. So because we have good and we have average and we have poor, then we need to calculate the Shannon entropy of good, and then we calculate the Shannon entropy of average, and then we calculate the Shannon entropy of poor, and then we put that into this formula. Okay, so this formula you will have to expand for yourself based on the general or generic formula. So you have to understand what are the attributes, what are the values for each attribute, and then you will be able to know the formula for the gain. Okay, and then it's time for you to calculate the entropies. So first, we need to calculate the entropy for good and average and poor. And in order to do that, we will need to know how many of them, yeah, how many of them. So as you can see here, we have the gain, the good and average and also poor. And we can see here that for good, okay, if for the good GPA, we have a 3 of yes and then 1 of no. This will be important later, yeah. For the GPA of good, we have 3 of yes and then 1 of no. So we will write it like this. And then in total, good, there are 4 records with good GPA. Okay. And then for average, in total, we have 4, but it's divided by 3 of yeses of the accepted and 1 of no. And then for poor, we have 3 records with poor, 2 yeses and 1 no. Okay. So we will be able to do that, to use this value for this one, and this one. Okay. And that means that we have this value here. Now, how to calculate the entropy of each of these values? Now, this is why we want to know the values here. So in order to calculate the entropy for each of the values, that means for the entropy of accepted, so this is accepted but good, yeah, accepted according to good, okay, that means we have to know the probability of good and yes, all right. So and then this is the probability of good and yes, and this one is the probability of good and no, and this one is average and yes, average and no, this one is poor and yes, and this one is poor and no. So in probability concept, this is called the probability of yes given good. Okay, this is the probability of yes given good. So what is the probability of yes given good? Well, if you are good, the probability of this yes will be 3 divided by 4, right? Because there are in total 4 of the good rows. So this is 3 divided by 4. So this is very often reversed. So please be careful when using the formula. Make sure that it is the correct one. All right. And we put that into this formula, and then we get the entropy for each of them. Okay, so this is the entropy for good, entropy for average, and entropy for poor. Next up is that we can calculate the information gain for the GPA, because we already have all the required numbers, and then we put them here. Okay, we put these numbers here, and then we put these numbers, and then this is the information gain of GPA relative to the output attribute, which is accepted. Okay, is that done? Yes, we are done with this step and with this attribute. So what we do next, we do the same thing. This is exact same thing. However, we are using the attribute for psychology. Okay, so we do all those the same things as before, but instead of using GPA, we are using the psychology, calculate the entropies for strong and for mode, and then for weak. Then we have these entropies, And after we have the entropies, that means then we can have the gain, okay, for the psychology. And the last one is we calculate the entropies for each of the values in interview that will be proper and unsuitable. So we will get the entropies for proper and unsuitable, and using that number, we will be able to calculate the gain for interview. Okay, so what happens after we have all of the gains for each of the attributes? We have gain for GPA, we have gain for psychology, and we have gain for interview. We choose the one with the biggest value. And in this case, the biggest value is interview. And if you remember before, the number one determining factor for acceptance was interview. So that was correct. However, this just means that mathematically it is proven that interview is the number one deciding factor here. Okay. So next, we will decide that based on this interview, we divide the original table into two smaller tables. Okay, into two smaller tables. So this is what we mean by it's iterative and also recursive. So if you remember before that the original table is much larger, and then they have more rows and also more columns. But since we already divided the table, the big table, into based on the interview attribute, and then the interview attribute has two values, and then we divide the table into, if interview is proper, then the table is just like this. So this is only the rows that have interview proper, and then we can remove the column of interview. Why do we remove it? Because we know that, well, all of the rows here have the interview of proper. And same thing for the interview of unsuitable. We will filter only of the rows that are having an interview of unsuitable, and then we can remove the attribute of unsuitable because all of them here are unsuitable. All right, so this is the end of recursive 0. Okay, so what happens about this first table? Okay, now if you recall, the first step of the first iteration is that we need to calculate the entropy of the output attribute here. Okay, but in this case, in the smaller table, yeah, not in the original dataset, but in the smaller table that has already been split. Now, if you can see here, all of yes. So if you remember the definition of Shannon entropy, if all of the values are homogeneous, that means the entropy is 0. So even without using the formula, you can know that the entropy of accepted here is 0. And if you use the formula, it will still be 0. So that means we already have a leaf node. We do not have to process this node again. So meaning that if interview is proper, then it is directly, it's a yes. So there is no more subtree here. Okay. So that means that we will need to process this table. Okay. So let's go to process this smaller table. And this smaller table, we do exactly the same as we do before. But in this case, we are doing it with the smaller table. So we calculate the entropy of A. So 2 divided by 5 is because we have 2 yeses divided by the number of rows, which is 5. And 3 divided by 5 here because we have 3 of the no, and then divided by the number of rows, total rows. And after we calculate the entropy of A, we will need to calculate the gain of GPA and psychology, which means we have to calculate the entropy of good, entropy of average, and entropy of poor, and then to calculate the gain here. And then we will also need to calculate the gain of psychology, which means that we have to calculate the entropy of moderate and weak, just moderate and weak here. And then we will get the gain here. All right. So we have the entropy of accepted based on moderate and weak. And then we also have the entropy of good, entropy of average, entropy of poor. Okay. And then we calculate the gain of accepted, the gain of GPA, okay, relative to accepted, and then the gain of psychology relative to accepted. All right. So after we have these two gains, now we know that the bigger gain is for psychology. So what happens if we have decided that psychology is the bigger gain? That means we will replace this decision tree that is previously a whole table with just the psychology. Okay, and then we split. We decide based on psychology. We have strong and we have moderate and weak. We know that there is no data in the strong here. So when we split the rows, it's gone. But for moderate and weak, we will have a sub table here that we need to process. And for weak, even without going to the entropy, we already know that the entropy is 0 here, homogeneous, all of them is accepted, so we can say that the weak is no. Okay, and if you're doing it again and again, so last one is basically this becomes no, and then this will be split again. Okay, so split based on GPA, you can see here, if it's good or average, it will be yes, and then if poor, and it will be no. All right, so it will be like this. So this is the end of the algorithm, and this is the result of the ID tree algorithm, and the result is a decision tree that we can then use to predict when given an unknown applicant. Yeah, so whether that applicant will be accepted or not will be decided by using this decision tree.